Welcome back, fabulous friends. So today we're talking about one of the main parts of GIS that allows you to do actual data analysis. Is going to be where all the data for your files is actually stored, and those are in attribute tables. So we're doing a lot of the work around the geometry of our data. So far you've looked at the difference between points and lines and polygons, how to navigate those shapes, seeing where those shapes overlap, how to draw things around those shapes, for example, doing buffers, doing clips. We learned a lot about map projections to make sure that your shapes are drawn in the correct way and they don't end up off in outer space, right? So far we've really been looking just at like the shapes, the shape data, right? Again, the points, the lines, the polygons. But what do all those shapes mean, right? Those points and those lines, those polygons, the reason why we do all those buffers and clips and those reprojecting for our coordinate reference systems is because we have to do analysis with what's inside those shapes, okay? So the big power of GIS is that within each of these shapes that we have on our layers is all this endless amounts of data. And this data falls into two different categories. Geographic data, which is what we've been doing so far, and attribute data, which is what we're talking about today. So geographic data is going to be associated with the actual location of your phenomenon. Again, what we've been doing so far. So you've been doing a lot of things, making sure that your layers line up correctly, that they're both in the same coordinate system, buffers and everything. So all these are going to be things like your latitude and longitude, which tells your GIS where to draw your points or line or polygon. Your street address, so geocoding is the act of making sure that your attribute data has an address associated to it. Zip codes, UTM coordinates, right? Anything that puts your blob into space. Sometimes geographic data is also called spatial data because it's related to space, right? Attribute data is all the other data, right? And this data is not specifically tied to location, okay? So it could be the color or the species, if you're doing trees or animal surveys, the year the house was built, the number of rooms, right? Democratic Party, whatever it might be, right? So you can see one's very much linked to location and one is not. And both are very, very important to do GIS analysis. So your geographic data gets that vector information, or raster when you eventually get there. Your vector information is plotted on your map, but then the attribute data allows you to do the actual really exciting analysis, okay? Your textbook have this great example of a house. I like castles more. But yeah, let's say you have a GIS database, a layer of castles, okay? Within your attribute table, you're going to have different types of data. So the geographic data you might have for your castle could be, again, latitude, longitude, or your UTM coordinates, or your state plane coordinates, depending on which your reference system is. Your street address, that would be linked to location. The name of your kingdom, for example, you know, city, kingdom, state type thing. A postal code. So anything that ties your data to the earth, to the location, okay? Move my face out of the way so you can read this one over here. Attribute data would be things like number of rooms in your castle. The number of rooms in your castle would be important if you're going to go be a castle realtor and sell this castle. You need to know that information, but it doesn't really tie itself to location. Therefore, we put it in the attribute data section, right? Architecture style, right? Is it French? Is it Spanish? Is it Baroque? Whatnot? Does it have a moat? Are there dragons allowed? I mean, these are very important questions because who wants a castle if you can't have dragons? I mean, what's the point, right? So things that are not tied to the location, doesn't help your data get drawn onto the map, are called attribute data, okay? Other things that fall into geographic data or spatial data are going to be the actual shapes if you have a polygon. So actually like the dimensions of your blob, right? So those are the two categories of data that we're going to be working with. So again, That's a castle. So you are a castle realtor, right? And you're going out and you have lots of clients and you have to keep track of all the different castles that you're selling. So maybe you make yourself a nice little spreadsheet, right? Stay organized. And so you have an ID for each, you know, each castle that you're selling. And you're going to have a mix of geographic data. So for example, an address is going to be very much linked to location, your zip code, right? And then you're also going to have attribute data. So your owner, because you need to know who your contact person is. Again, dragons, yes or no, most important question, right? So this here, you know, I said it could be a spreadsheet, Excel spreadsheet, but really this is going to be the basis of your attribute table. And so within an attribute table, we actually have certain terms we use to identify the different pieces of this table, okay? So each individual castle is going to be a record, all right? So, you know, you only have 5 castles here, but if we were looking at, you know, Social Security data for everyone born since 1890, it would be a massive table, okay? So actually having a record, that record is going to be that specific entry, okay? There's no shape information linked to it as an example, right? But each record would be its own dot on your map, or its own line on your map, or its own polygon on your map. So every record correlates to a specific thing on your map, okay? And then the attribute is going to be the thing, the variable, I guess, the thing that you are studying, right? So for example, if you want to just know the owners of all the castles that you're selling, this attribute row here would be the most important thing. I want to look at the attribute of owner. I want to look at the attributes of year built. I want to look at the attributes of, does it have a moat, you know? And so you can sort by that. And as you start doing analysis, you know, maybe you only want to map castles that allow dragons. So you would be able to hone in onto that attribute and really ignore the rest of it because it might not be useful for you, okay? And then within each individual cell, the value is going to be the actual information you put there, okay? So every record has values, every attribute has values. That's going to help you, again, do analysis and do data, all right? Attribute tables are great because they organize your data, but they also are linked to a physical representation on your map, which again, makes it GIS and not just a spreadsheet. Now, it is possible to take an Excel spreadsheet and turn it into an attribute table. It's a little more complicated, so we'll do that later, but that is an option. It is an option to upload an Excel spreadsheet into a shape file to make that attribute feel that way. I don't recommend it, but it's doable. Okay, so how do you organize this? So let's say, again, you're a castle realtor and you have your fancy list of castles for sale. And as we saw on the last slide, each castle had an ID number, all right? Well, before you close a sale, you have to go back into the township records and make sure none of your castles are on the under siege list. Because no one wants to buy a castle under siege. Sieges are messy and just end poorly for all involved. So let's just skip that. So now you have 2 different lists. You have your list of castles for sale, and then you have the list of castles under siege in your township. How do you get those 2 to communicate? Well, let's pretend they're both really big, right? They're both big giant files, so you don't want to like flip through each one, okay? This is where a key comes in. So as you saw on the last one, we had attributes that had like, you know, an owner and address. A key is an attribute that is unique and can link multiple databases together. Uniqueness is the important part. For example, as you saw on the last one, it just said ID, and like, that's not very helpful. But things that aren't going to be repeated, so social security numbers, everyone has their own, parcel numbers, right? Things that are going to be very, very specific to a certain thing. ISBNs for books, right? Or UPCs or whatever you are, you know, scanning. Credit card numbers, I don't know, right? Things that are not going to be repeated. They're kind of, your G number would be a great thing, right? Your G number is assigned to you throughout your time in the San Mateo Community College District. If you go from being a student to being an employee, your G number stays with you, right? So G number would be a great thing to use as a key, okay? how this works is you want to have, I think I have on the next slide. Here. So as you saw on our castle example, we just had object ID, and it's like 1, 2, 3, 4, 5, kind of like this FID right here. Now it is nice to have that kind of attribute because for your sanity, maybe you just want to know, okay, what record number am I looking at? How many records do I have? So it's nice to have something that's very logical and goes 1, 2, 3, 4, 5. But you can't use that as a key because 1, 2, 3, 4, 5 is not a unique number at all, right? So looking at this list here, this is from ArcGIS, right? Which of these would be a practical key, right? We can't use zoning because they're all the same, they're all residential. We can't use state, because it's all Colorado, right? With our zip code, I see a lot of repetition, right? Address is possible, you know, there's no repetition here, although I'd be willing to bet that somewhere else in the United States, there's going to be another place called 7318 Silver Moon Lane, right? Totally possible. How many main streets are there in the United States? You know, how many Washington Boulevards are there? So we need something that's going to be very, very unique. And so that's where, again, they have here your parcel ID would be the best because it's a very long string of numbers that's not going to be repeated. And again, a lot of things linked with the government are going to be set. They have to be like unique to that person or to that piece of property or to that you know, government building and so on and so forth. Okay. So if we were to use any linking, we would want to go for parcel ID. So the thing to think about when you look at your data, if you need a key, what would it be? You don't always need a key, but it's good to know what your key would be. So talk about values being the specific things that go into each of those little boxes. But there are going to be rules about those values, okay? Again, working with a computer that likes to have things very logical and very, very binary, right? And so within your attribute column, you'll actually, excuse me, as you click on that attribute to learn more about it, you will see specifically the rules that it has for what is allowed for your values, okay? So values themselves have 5 types. Character, which is pretty straightforward. So it's going to be text or sometimes called a string, right? So example, you know, when I wrote the word, you know, Count Dracula, that would be the character type because I'm using alphanumeric and it could be a combination of letters and alphabets and numbers, you know, so it's just text. Integer and floating are both going to be number types. And the difference is actually, the difference between integer and floating is much more complicated than this. It has to do with how the computer processes them. But for this lecture, we're going to separate them into integer is whole number and floating has decimals, okay? Again, there's a lot more, floating has more flexibility in terms of what computational power it has. But for now, we'll just do yes decimal or no decimal, okay? So again, if you're doing number of rooms, well, buildings only have 1.5 rooms. It's either a room or it's not. So that'd be a good one for integer. Versus baths could be floating because people totally have half baths, right? Or how tall are you? You know, that's a great one to have decimals for. Date one is going to be pretty straightforward. It's dates and times. And then there's blob. I just like saying blob, but blob is binary large object. This one is used less often in analysis and more comes into that organizational type of work we do with attribute tables. It's really great for, so a binary large object is going to be MP4 files or photos, you know, any type of large data piece that you're going to be attaching. Great examples of this are going to be if you're doing surveying plants and you have photos of each plant, stick that in your blob value. Perfect, right? And that way, if you're the person collecting the data and then you ship it off to your GIS tech, then they can go through and say, oh, cool, there's pictures of everything. I can actually go through the pictures. Or a video that's a tour of the house or, you know, whatever it might be. So photographs are gonna be the big one that you use with this one. Videos can be as well, but all the ones I've seen are all in photos, okay? So those are the 5 types of values you can There's also more rules around values, like can they be repeating, right? Did I have that in the next? I don't think I did. Can they be repeating? So for example, can I have Maleficent on my attribute table twice? Sure, she could totally have more than one castle. That would totally work. But you're probably not going to put down that, like, you know, I can't think of it when you repeat. Well, she doesn't have 2 social security numbers, for example, right? So you're going to tell your attribute table, yes, you can repeat Maleficent for owners, but you can't repeat her for social security numbers, right? Was there a limit to how long it can be? And this goes again into the processing power. So again, back to the integer versus floating. Sometimes you'll have a limit of, it can be 2 digits, the end. And sometimes it's going to be like 999, and you have this giant chunk of data that's kind of far for you. But yeah, limiting your data so you know how much space it takes up, because all of this data has to live somewhere, and that takes space. Now that we're more and more moving to the cloud, it's less of a concern. But when I first started doing GIS, we held all of our data on USB drives, and that was that. And if it was too big for your USB drive, then you were in trouble, okay? So these are the 5 types of data that you're going to have within your values. Okay, so what happens if you don't have data? And any of you who've ever collected data knows that sometimes you just don't have data, right? You forgot to survey something, dog ate it, right? It was built after you did your research. There's lots of reasons. Your lab tech quit halfway through the season. Yeah, there's lots of reasons why you might not have data. But we have to indicate that within our attribute table, okay? So leaving a blank is not really good, because then it's just kind of, it doesn't work. So we use null or -999 or +999 if that matter too. But yeah, null is the most common one that you'll use. I know QGIS uses null a lot. And this is the way of saying there's no data here. We just don't know, right? You don't want to use 0. Right? I know that's kind of an instinct. It's like, well, if I don't know, we'll just put 0, right? But 0 actually has meaning, right? So for example, if the question is number of bathrooms and you don't know, and you put 0, well, that tells me that there's 0 bathrooms in this house, so I don't want to buy this house, right? So you don't want to use 0 unless the actual value is 0. So null is the way to go. Null universally means, no, don't know if there's dragons. Good luck, right? So one of the most common tools that you're going to use for your attribute table is join. There's, of course, a lot more. This is kind of one of the really, really big ones. And the nice thing about joins is it also shows the importance of your key, all right? So this is going to be, again, you're going to go sell your castle, and you have your list of castles for sale, and you have your list of castles or sieges, and I need them to connect, right? So if I have 2 different data sets, how do I turn them into one? So for example, here I have one list. Let's say I got this from HR, right? Hey, HR, I need a list of tax stuff, right? So they took the names off for privacy. But every person has a special code, right? And it's like a G number. Only one person has that code. Yeah, okay, here's their job, and here's how much they make, and here's their employer, right? And then maybe I go ahead and I talk to, I don't know, who else forwards data at the companies? The other HR person, right? And they have a different spreadsheet. Maybe it's hire dates or something. And they have the name of the people, their age, their species, right? And they, again, have that list of that code, your G number, your CID, your social security number, whatever it might be, that links specifically to your person. Well, I want this to be one data so that I can do analysis. I want to know how many monsters are teachers, and I want to know how many humans did Big Bird hire, or so on and so forth, right? I need to actually combine this data. Well, conveniently, let's look at this and say, are there any numbers here that are exclusive that would be very good for a key? And both of you, in their key you use, both attribute tables have to have, because of how they communicate, how they link. So for example, the occupation, explorer, teacher, superhero, I don't see that anywhere over here. So yeah, it's unique. I only have one teacher in this table, but it doesn't speak to the other table, okay? Same with age, okay? Yes, I only have one 6-year-old, but it doesn't communicate to the other table. Versus my CID, I have those exact same numbers are also over here, okay? And usually if you see something that says like ID, not always, but often, that leads itself to being a really good key because ID numbers don't generally repeat, okay? So in this case, I would use the CID for my key. And when I perform a join, I would tell the computer this. It would make one nice big table for me, okay? So this would be an example of a successful join. Now this is massively simplified because it all fit up very nicely. And guess what? Real world data doesn't do that, as we shall see in just a moment. So yeah, that's one of the common things that we do for our, let me go ahead and pull up. So now I'm going to show you some real attribute tables within QGIS. Of course, none of them have appropriate keys, but we'll talk more about that. Let me go ahead and share that screen. Okay,